In the application architecture courses that I created, I talk a lot about the principle of separation of concerns. And that notion of the separation of concerns is true at so many different levels, whether it be from a macro or a micro perspective. So at an architectural level, the way that we used it previously, we saw how useful that idea was. But now we're going to apply it at a much more granular level with regards to objects and the responsibilities that we assign to them. In fact, as we go about learning more about object design, we're going to learn about SOLID patterns, SOLID. Each letter is an acronym for one principle of object-oriented programming from an object design perspective, not necessarily architectural. And the S in SOLID is for separation of concerns. It's perhaps one of the most important of all the principles that we'll learn about then. I just want to talk about the different roles that objects can play in a system and talk about how we separate concerns out by the type of role. Now, this is not object stereotyping. We talked about that, or role stereotypes like we talked about previously. I'm looking at this now from a different facet. And there are really two different roles that an object can play. There are domain-specific objects and there are application-specific objects. So a domain-specific object are objects that are used to model the real world into an abstraction that we'll use in our conceptual machinery to create a solution. And then there are application-specific objects, and those are objects that are required in order to perform system-related tasks. So we'll use them for persistence, for display, whether it be on a computer display or web page, whatever the case might be, for communication over networks, so on. So we have domain and application-specific types of objects. So let's start talking about what is a domain object. Domain-specific objects are born from an analysis of our problem domain, and these represent, again, abstractions of the real world specific to our particular type of application. In fact, domain objects represent concepts that will probably be familiar to users and experts within a given specific field of interest. So that's one way for us to know. If we talk about databases, only DBAs or programmers might understand databases. But if we talk about accounting, somebody who's an expert in accounting should understand, ledger and accounts and things of that nature, right? So even an end user, somebody who's just entering in expense reports, they should be able to understand some of the basic foundational domain objects related to accounting. So the domain is made up of information and services that the user needs, along with structures that can relate the two, both information and services. There are also containers for domain logic or business logic, code logic that is expressed purely in domain terms. So, if you think about, for example, a part of an application in our sales system, we might need to determine the amount of money that we collect as tax on the sales of certain items. So there might be a lot of things that go into determining the right kind of tax and the right kinds of taxes to apply to an object that we must collect and then obviously send off at some point to governmental agencies. So a lot of it will depend on where the buyer is from, what type of business that they're in. So in certain countries, I might need to collect a value-added tax, like in the UK. In other countries, the amount to collect varies by state, country, and city. It varies also based on the physical locations that my company operates in with a physical presence. It'll also vary based on the type of customer, whether it's a business customer, a nonprofit customer, a government customer, whatever the case might be. But you can see in those instances, we're speaking now purely in terms of terminology that could be understood by a domain expert, a tax expert at a company, right? So those are going to be domain objects. They're concerned about the problem domain, not about all the other junk that has to go on to make this into a computer system. That's where application-specific objects come into play. So application-specific objects are born purely from our own imagination and are kind of like bridges between the domain world and the software world, right? So we're going to write these application-specific objects to kind of wrap around the computer world so that it can interact with our domain world, all right? So we'll create a set of of objects that interface with the network, with the screen, or output into some file format like HTML or XML or JSON. It'll interact with the database for persistence or some caching mechanism. It will interact with the file system or know how to create a file of a specific file type, things of that nature, right? And so when you are a C# developer, you're kind of up several layers of abstraction away from the actual hardware. In other words, I don't work directly with the network port on my computer. I don't work directly with the video port on my computer. I don't work directly with the hard drive. All those things are kind of abstracted. You have the operating system level, one layer of abstraction above that. There's an API on top of that. Then there's the .NET Framework API. And then we get a chance to write our code on top of that layer. So we're thinking in terms of layers here. And what we're going to do is probably write our own application-specific objects that work as a API of sorts that will marry our domain objects and allow them to be printed to screen or allow them to be persisted to disk. And then it calls the necessary methods inside of the .NET Framework, which calls the necessary APIs in the Windows libraries, whatever those are, which calls the necessary low-level APIs to magnetically change, a 0 to a 1 or an on to an off inside of a processor or open up a port, whatever magic goes on under the hood there, right? So that's the job of an application-specific object, to kind of be that bridge between the business world and the physical world. And as I look kind of at the .NET Framework API itself, the Entity Framework is really a good example of marrying these two worlds together. In the case of the Entity Framework, some of this is done automatically for you. It'll generate code for you based on some tooling in Visual Studio that will make this whole process a little bit easier. So you've got your domain, which might be like, a book has an author has royalty, has a shipping address, things of that nature, right? And then you model all those as domain objects. Then you tell the Entity Framework, go off and build code that knows how to persist those into a database. And so if you ever open up the code and you looked at it, you would see that it does that mapping for us. It's doing the mapping between worlds, the domain world and the software world that interacts with a underlying database, and everything else in the middle it takes care of. We could write all that code ourselves. We don't need Visual Studio's tooling for it, but it makes it a lot more convenient. But that's an example of something that would be application specific. All right. So we might have other objects that perform the role of coordination between the domain and the physical computer systems APIs. We usually call those services. We'll talk about those later. We might have still other objects that perform more utilitarian functions in the system. These might be good candidates for reuse, and we'll talk about those later. Well, here's one example, and we'll talk about this concept more at length, I think, in the next lesson. If we need to process a given file in a specific way in our system, there's a chance that other people in our organization might need that same processing feature. They may need to save the data in a specific file format specific to your company, or maybe just, a file format that's new and nobody else has built a library around. And others can then gain the benefit of it by you taking those application-specific objects and kind of packaging them up in a certain way, and then being able to share those objects in a package with other people in your company or in the world at large. And a great example of this is actually JSON.NET by James Newton King of Newtonsoft. Even Microsoft's new APIs rely on JSON.NET for handling JSON. It's everywhere. I'm not sure there are many .NET applications, many applications you and I have built here on DevU that don't use JSON.NET in some capacity, right? But at any rate, ideally, you would collect those objects together, separating them into neighborhoods of concern, and then package them up for reuse. And we'll talk about that in the next lesson. But in this lesson, I wanted to kind of make sure that we understand that there's a fundamental difference between domain and application-specific objects and what we mean by that. It's going to come into play a little bit later, so hang on to that thought, and we'll talk about it in a bit. Thanks.